This video is to go over the technique that I demonstrated in class about factoring a trinomial when a does not equal 1. And so we have been talking about this standard form of a quadratic, a quadratic equation. And when we've been doing the little cross factor tool here, we've been using a times c in the top and b in the bottom. But if a is 1, this top little v has been just the c term. And that's made factoring really easy. It's why we call them easy ones. However, when we have a trinomial, let's just use one of the examples here, like this. Okay, a does not equal 1, and we can't factor it out. We should always look to see if we can. Oftentimes we can create an easy one. If this was 12, for example, I could factor the 4 out, right? But it's 15, and there is no factor of 4. So this would be a candidate for using the little magic box method. And this is how it works, okay? The first thing you do is you multiply a times c, okay? So this time we won't have just 15 in the box, we're going to have 60, positive 60. And then b is negative 16. This part of the process is exactly the same as what you've been doing before. We look for two numbers that sum to negative 16, but that multiply to positive 60. And that does mean that they're both going to have to be negative, all right? So we can do some combinations of what makes 60, but what may hopefully have popped into your head is that if I multiply negative 6 and negative 10, I get 60. If I add negative 6 and negative 10, I get 16, okay? And one of the things I pointed out is you can't do what you can do with an easy one, which is just say, hey, I'm factored now, right? I can just drop those two in there because obviously x times x is not 4x squared and negative 6 times negative 10 is not 15, right? So we have to do something different with these two numbers. But the idea actually is the same in that in the other box, these really gave me my outer and my inner terms. So we're going to use that knowledge. And what I'm going to do, I usually just draw a little T here. I put the first times first term in this box. This is my last times last term in this box. And then these two guys give me my outer and my inner. Okay, and it doesn't matter which of these two sides you put it in. You will always get the same factorization. If you swap them from my position, what you have up here will be over here for me, but they're still, the two binomial factors will be pulled out of here and factored out in any case. I am just going to put the negative 6x here and the negative 10x here, okay? And then I just kind of draw my little box around. And now I just start factoring. And again, it doesn't matter what order you go in. If I have two negatives, I do have a preference for factoring that one first, because then if this was a negative, I know a negative had to be here. In this case, where the negatives are, it's not going to be abundantly clear, so I'm going to wait until the very end of the process to put the signs on. I'm just going to factor out the numbers. So what's common to 15 and 6x is a 3, okay? What is, and again, you go in any order. What is common to 4x and negative 10x is a 2x. I'm ignoring the signs for now. I know I've got to have a 2x here because 2x times 2x have to give me 4x squared, but that's also the common factor in this row, as it should be. And then the common factor in this row is a 5, okay? And then this is where I just take a look and say, well, what do the signs have to be? Well, to get a negative here, I'm going to need a negative, and I'm going to have a negative here as well in order to get a positive 15. Okay, so that's kind of how you do these. And the final factored form would be 2x minus 3 times 2x minus 5. Okay, and if you do the box, you will get the correct factored form the very first time. And just to kind of point out that we could have done guessing and checking, but there's lots of ways to get 4. There's 1 times 4, and then there's 2 times 2. And then there's lots of ways of getting 15. There's 3 times 5, and of course 15 times 1. And so, and then you also have signs going on here with the negative. So if you're trying to do a guess and check, you have a lot of different possibilities. This is going to be the way to go if you have what I would call factor-rich numbers up here. One thing I did not show you guys in class, though, that did come up in the quick check, is I'm going to show you something real quick here. That is if you have a problem like this one, okay? Okay, now technically, this is one of those that you'd say, hey, yeah, A does not equal 1. However, 2 is prime and 3 is prime. I'm going to tell you right now that if this will factor, okay, the only way to get a 2n squared is if I have a 2n and an n, right? And the only way to get a 3 is a 1 times 3. So I either have to have a 1 times 3 or a 3 times 1. Those are really the only possibilities. And there's also a negative sign in here. But what I hope you notice is this is the type of thing that I could do some guessing and checking, okay, if you wanted to do it that way rather than do the X tool in the box. So what I think is I need something, really what I need is, I need something that will multiply. I need the 1 and the 3 to be in a place where I've got a plus minus that will give me a positive n. And to me, that means I probably want 3 minus 2, right? And in fact, that turns out to be the factorization. Here I'm going to get 3n minus 2n is positive n. So when you don't have, when your C term and your A term are prime numbers and there aren't very many possibilities, particularly if they're all positive, you might as well just do a guess and check because there aren't that many things to guess, all right? Another good example would be, let's see, I had another one on here. Okay, this one was, I think, number 6. And this one said 18k squared minus 12k minus 6. And if you notice, if you pull the 6 out, right, the greatest common factor here, I've got a 6 times 3k squared minus 2k minus 1, okay? And again, this one's even easier because if you think about this, again, the only way to get 3k squared is 3k times k, and the only way to get 1 is 1 times 1. So if this is going to factor, this is the only way to put it together. I just have to look at the signs. And I look at this, yep, I'm going to have negative 3k plus k is negative 2k. So just because A does not equal 1 doesn't mean you must use the box, but these are pretty simple. You know, 1 is prime, not prime actually, no, not technically, but there's only one way to make 1 times 1, and 3 is a prime number. So you really have very few possibilities of how to put them together. You can do a guess and check. When they get to be a little bit more complicated, when we start having A and C have numbers that have a lot more factors, you know, you start putting in 4 or 12 or 36, right? All these have many, many different ways I can make up those factors. And for those, you'd use the box because you will get the correct factorization the very first time. Hopefully that was helpful.